Welcome back. This is the first part of lesson 6. In this lesson, we will discuss the code used in the encryption in real ransomware. I've created an empty file. First, I will import the required library cryptography from cryptography.fernet. Import fernet module and also import os.path, which make us reach to the file, and also import time module, which we'll use to measure the time of the encryption process. Okay, I will create a comment to indicate what I'm doing. Here I will generate the key, and we agree that key can generate using fernet.generate key and print key like this. Here is the key, and in each run of this file will give us a different key. Focus on the last 3 characters, P and Q. Let's run again. BC4. So in each run for the generate key function will give us a different key, and different key mean different ransomware, because each ransomware is specified by its key. Changing the key make it possible. It's impossible to decrypt the file with different key, except the key which used in encryption. Here is the function. In the encryption function, if encrypt, and I will pass here the file in name. I will open the file, and here we'll pass the file name to the open function. I will open the function to read its content as binary, alias file. I will create a variable called original1. In this variable, I will store the first 10th character of the file, and also create another variable called original2. In this variable, I will store the next 90 character after those 10 character. Let's print original1, and also print original2, and see the result. Let's call the function encrypt and path the path of the file to this function. Here is the function I'm gonna try on 2.1 and 2.2. Those two text files have the same data. Let's open. I will encrypt one of them, which is 2.1, and use 2.2 to compare between the two files. Okay, let's run. Here Okay, I'm so sorry. Two point one. What gives us? Okay, this is the encryption key. Let's eliminate this and replace it by the key. So we have a constant key. Let's run again. Here is the first print, which is the first tense character of the file hello how, as you see. After this, you will notice that it complete after those tense character and copy from RU, count 90 and stop. Let's see the 90 character. Stop where? Stop at what is U. Where is what is U? Here. It started from after how to what's U. Those are 90 character. And as we know, the first read take the first tense character and the pointer stop here after 10. The next read complete from after the previous read and count its character. So the next read or the second read complete from where the pointer stop from the previous read. The previous read stop after 10th. The next read complete from 10th and count from 10th to its character 90 and stop here. If I read again, it will read from R and count its character and stop. Okay. Let's complete. I will encrypt. Using Fernet, and I will pass the key to Fernet. Use encrypt function, I will encrypt original one, which is 10th character. Why I encrypt part of the file? Because encrypting part of the file will save time. Because the encryption process take a lot of time or take very long time. To reduce this time, we encrypt only part of the file, which is the first 10th character. Okay. Let's print line, which is the encrypted text of the first 10th character. And also let's print the length of line and see the result. Here's original one. Hello how, and here is the next 90 character, don't concern with them. Here is the encrypted text, which is line. The length of this encrypted text is 100. Okay, so I read 10 and 90, which is 100. To replace them by 100 encrypted text. And I will remove or convey those 90 characters to the end of the file. So I read 100 characters, I encrypted the first 10th of them, and the remaining, which is 90, I will transform them, or I will transport them to the end of the file. and store them at the end of the file. Because in the decryption process, I will copy them and put those 90 characters again to their position at the beginning with the first 10 character decrypted. Okay. Here is the pointer at the after 100 letter. I will make the pointer go to the beginning of the file by seeking 0. I will write in the file at position 0 the encrypted data. Okay. And open the file again after writing on it. Which file I will open? This is its name. I will open the file in append mode. Why I choose append mode? Because append mode add to the file without deleting data on the file. Which means append mode add string to the old data in the file. Okay. Here's the alias f2 dot write, but the mode is append, so it append not write. Original 2. Okay. I read 10 and 90 character, which is 100. I replace those 100 by the encrypted text of the 10th character, which is this. After this, I put the 90 character at the end of the file. Okay. Let's run and see the result. Let's go to the file again and see. Here, here is the same file. Let's compare between them. Here you have hello, how. Okay, which is the first 10 character. And here is the 90 character I read after this 10 character. You will notice that those 100 character is replaced by the encrypted text for the first 10 character. Here the first 10 character, I encrypt them, and this is the encrypted alternative text of the first 10 character. Okay, the first 10 character is encrypted by this 100 text. But where is the next 90 character? The next 90 character which is those from R to U is put at the end of the file. You will notice them here. Okay? Here's what we have done. You may notice that encrypting part of the file is a useless process because we are still able to read the remain of the file. But this is not correct because this happens only in text, and I'm training you in text files because text files are being able to open as English text and you can read its content. But MP4 videos or MP3 or even games exe files are open as binary, and you can't understand their content because they are encrypted by base 64 encoder. Let's see what I mean. Here you still able to read the remain of the file, and this is true. Let's try this encryption process on video or exe file program. Here, songs. Here is video. Let's take the path of the video and put it here. And let's take this video. Dot M4. Let's encrypt. First, let's run the video. You notice that the video is correctly open. Let's encrypt this video and see the result. You will notice that the content of the video is binary encoder, as you see, x00, 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 and you can't understand their content. Let's return to the file and try to open it. I think you see the message here. Can't play the video. Why this happened? Because encrypting part of the file make the file unable to play, and this is what we need to damage the file only. This can be useful with RAR and ISO file and big data, which will consume a very big time to encrypt them, but encrypting part of the file just take 1,000 of second, which is very small time. By this